all, welcome back. So today in this video we'll study about typecasting in Java. So what does typecasting means? Typecasting means converting one data type into the another data type. That is, now you should not get confused what is a data type. We have already seen different primitive and primitive. There are two types of data type basically, primitive and non-primitive, right? So here we are talking about the primitive data types conversion. So the typecasting means converting one data type into another data type. In simple words, it is used when we want to change the type of a value or a variable. For example, you have a variable say x that is having a value 10 and it's of integer type. Now you want to store, can you store this in a double data type like double y equals to x? Do you think will this work? Yes, because int is of like smaller size and double is of large capacity than the integer. So double can store into data type and this will work fine. But what if you want to do the opposite? You want to store the double value in the integer. Then the question comes up. Then you won't be able to convert it simply because there might be chances if you have some double value say 10.007.019. So when you convert this double to integer, your these values after this decimal point will get lost, right? You will lose some data. So to avoid that, how can we like in directly we can't convert, so we need to give confirmation to Java through programming that we are ready to lose our data and we are ready to lose the values after the floating like decimal point, and you can convert it to integer. So there comes the concept of typecasting. So here, if you are converting a smaller data type to larger, that can be done automatically because the large, if you think of it as an example, you have a small box and you have a big box. So whatever data you have in a small box, that can also be occupied in larger box, right? That complete data can come in larger box also, and there will be some space left or something, that all things you can think of. But what if you want to store the data of larger box into smaller box? Then you have to lose some data, right? Your data will get lost somewhere. So how this convert? First of all, we'll discuss why do we need typecasting? Because we know different variables or stores different types of data. So sometimes we need to convert one data type to another. For example, decimal to integer or integer to double, or we need to convert some object conversion, or for memory optimization or compatibility between types, we need the typecasting. For example, you pour a water from a small glass to a big bottle. That is very easy. But if you try to pour water from a big bottle to small glass, then there is a risk of overflow and spillage, and your water will get like wasted. This is the same concept we have in Java. Now, there are two types of typecasting. One is called as implicit typecasting and another is called as explicit typecasting. Implicit means widening and explicit means narrowing. Widening, the name is suggesting that you can widen the, you can put the small glass water into the larger, you can widen your scope. Now, so what does implicit typecasting and widening means? It is also known as automatic casting because I told you if you want to convert into to table, that will be done automatically. So this is also known as automatic casting or upcasting. In primitive context, in Java automatically converts smaller data type into the larger data type, and there won't be any loss in your data. Now, how this conversion order works for this implicit type of conversion? We know the size of byte is very small, then greater than that short come, then int is greater than short, then long is greater than int, float is greater than long, and double is greater than float. So if you try to convert a byte into short, it can be done automatically, and from short to int, it will be done automatically. If you try to convert int into long, that will be done automatically. If you try to convert long into float, that can be done automatically, and if you try to convert float into double, that will also be done automatically. That is implicit casting. Okay, for example, here we have a integer x whose value is 100. If we try to convert it in a double, so it will give us the correct output, and in double it will append dot zero at the end, and Java automatically does this conversion. I'll show you all these things in editor. For now, just go through the concept first. Int can be directly converted to double. Now, why widening is safe and why narrowing is not safe? Widening is safe because larger data types can store smaller data types safely. If you are trying to convert integer into a double, your data is not getting lost. So this is safe, but opposite is the narrowing concept. There are the chances of your data loss, so that is not considered as a safer approach. Now, here is another example where you have a character A and you try to assign that character to an integer. That is, you are trying to convert a character to an integer. And remember, there is ASCII table or ASCII codes in which capital A is being denoted by 65. So whenever you will try to convert this character to CH, you will see and try to print it, you will get a value of 65 as an A here. Okay, because a sky or Unicode code for A is 65. Similarly, for B is it's 66. For C is 67. You can Google a sky table. It will show you the codes of all the letters, small letters and capital letters. Now, another topic is explicit typecasting. That is the second approach that is also known as narrowing or manual casting. In this, we also call it as downcasting, and it is used to convert larger type into a smaller type, and there are chances of data loss. And Java do not do it automatically. The syntax of it is you will write the data type, you will write the variable name, you will now in bracket you will again write the data type, and then you will write the value. Because narrowing may lose data, Java forces programmer to perform this conversion. That is why it is known as manual casting. Okay. For example, here we have a double x which is having a value 10.75 when it is being converted to integer. This way you can convert like int variable name, and then to convert it in round bracket we are converting it in integers and x. This will print the value as 10 now, not 10.75, because we have converted our double into integer, right? So decimal part will get removed. Now, why explicit casting is needed? Because narrowing may lose data. Java forces programmer to confirm the conversion so that in future, if somewhere you want to get rid of it and you said like, no, I don't want integer, I am happy with my double value. So you can remove this code, but like you will be having some uh, part of code written in your application. Now data loss in narrowing. You have an integer value 130. When you try to convert that to byte, so what will happen? You know the range of the byte is from 1 minus 128 to 127. And if you try to like convert 130, that is larger than that of the size of the byte or the range of the byte, we can say it is like byte can be only from minus 128 to 127, but 130 is coming after 127. So there will be chances of data loss. And if you try to print it, try to convert it into byte, then the output will be this. I'll show you this in editor, then it will be clear to you. Now, what is primitive typecasting? Primitive typecasting conversion means if you are converting the primitive data types like int to double, double to int, or character to int. These are the most common typecastings. Now, there is another thing for object typecasting for non-primitive also. Now we are seeing for non-primitive data types. Okay. Initially, we have seen for primitive data types. Now, object typecasting in Java. It is used with either inheritance or parent-child object. Now, inheritance, yesterday only we have gone through the concept of OOPS, in which we have seen inheritance basically means when a parent class is having some behavior, properties, and methods, and a child class can extend the parent class and use the methods and behavior and properties of a parent class. That is a parent-child object relationship also, and the inheritance concept also. Now, upcasting in object. Upcasting means upcasting means widening. Widening means it was being done automatically in primitive. So child object referred by parent reference here. For example, we have a class animal and dog is extending that class. We have created a object of dog class here. This is upcasting. We are typecasting here. This is being automatically done because dog is already extending the animal, right? It extends animal already. So this is very safe. And why do we do a typecasting? Because child is a parent, because child can access all the properties and methods and behaviors, whatever parent have, child can access those. So this is safe, and dog is a animal is just to denote the relation. Okay. Now, downcasting in objects when parent reference converted back to child reference. Here, this is known as downcasting, and here manual casting is required. When you are trying to like convert the parent reference back to the child reference, then this is known as downcasting. And here, if I show you the complete example, we have a class animal, and then we have a sound method, and then we have a dog class that is extending the animal, then we have a bark method in dog. Okay. Now when you create a main method in main class, you have created an object A for using the parent class animal. But here you are trying to do the conversion and you are trying to call the method bark that is in class dog, and you are trying to call it using convert it, right? Then you will get the output, and this is known as downcasting. You are trying to convert the parent reference back to the child. Parent reference was this A, and you are trying to convert this A back to dog, that is child. Here, remember, parent reference converted back to child reference. Converted back to child reference. Always remember this line. By this, you will be clear about downcasting. This is we have discussed about non-primitives. Okay. Now what is invalid casting? Invalid casting means when you get something like class cast exception. What you are trying here, you have a object of animal class. Here you don't have dog constructor, right? If you have dog constructor, then this is completely fine. But if you have an object of animal class and you are directly trying to convert it to dog child class, then this might pose you the error class cast exception. Okay. Now, another topic is type promotion. Java automatically promotes smaller types during calculation. For example, if you try to have 2 bytes and you try to calculate their sum and you want to store it in integer, then the result will become integer itself and you will be able to perform arithmetic operation, and the byte will get automatically converted to int and the result will get stored in this integer only. Okay, this is called type promotion. One type, smaller data type, you are converting to larger one. Now, ASCII conversion using casting. We have already seen that this was the character A, and character A in ASCII table has a value 65, and if we try to convert that character into the integer, indirectly what we are doing or directly what we are doing, we are converting a smaller data type into the larger. So this can be done automatically and you will get the output, correct output. And if you try to convert into character, then what will happen, you have to do it manually. It won't be done automatically. You have to do downcasting because integer is of larger size than as of character. Then you need to do it this way. You have to typecast it, right? And once you typecast it for 66, I already told you will get a value as B. Now wrapper class conversion. We'll see in later videos what do I mean by wrapper class. For now, just this is the advanced casting concepts. For now, you can skip this part. Okay. Now, what is the difference between widening and narrowing? Widening means you are increasing your scope, smaller to larger data type conversion is being done, and it can be done automatically. Your data will not be lost and it is safe. Whereas widening, in which in narrowing, we are converting larger data type to smaller. So we need to programmatically give the confirmation through Java program. So it is done manually, and here data loss is possible and it's very risky. Now, common mistake what students make is they think narrowing is automatic, but it is not so because we need to give confirmation using Java program, and this is manually we have to cast. And another mistake what student can make ignoring the data loss. For example, if they try to convert double into int, they will, if you are creating a small application where you don't need this and you are not sending it in a production and with data loss you don't have any issue, then it is fine. But if you ignore this data loss, then if you are in a real application and you are trying to deploy that application later, it can cause you some problem when your data will get lost. Now, third mistake what student make is invalid object downcasting that sometimes cause class cast exception. Okay, that we have already seen. And the fourth mistake, confusing primitive casting and the object casting. We have both seen both primitive and object casting. I think in one go you won't be able to understand this. So for this, I will suggest you to watch this video twice so that you can get the better and clear understanding of all this topic. Now one super short revision we'll see. After we'll see first the example in the editor. So I hope you can see my editor. Here we will create one file. Let's say the name of the file is typecasting example. .java will be the extension. Now public class typecasting easy. Now public static void main string arguments. Now what you have to do, for example, you have a say integer num1 equals to 10. Okay, you want to convert it into double. So what we are doing here is like automatic casting to double. So what will happen if you try to directly assign double num2 equals to num1, and if you try to print here num1 value of num1, and similarly if you try to print num2, you will clearly see the difference. I'll just run this program. You will see it automatically will get converted to double, and you will see 10.0 for this num2 value, but your num1 will be 10 only. Mm, I'll try to like, error class typecasting example is public, should be declared, and this is not an issue. Okay, DYY we need to write. I just misspelled the file name, was not same as the class name. So I need to make this change. After that, this will work fine. I'll just try to compile it myself and then run this. See, here the num1 is 10 and automatically it got converted to double value. This is the concept of automatic casting. Another is the concept of manual casting, right? If you try to convert integer to character, then you need manual casting. For example, if you try to convert a character or a character to, let's say we convert, so sorry, I misspelled it. If you want to convert a character into an int, the character size is smaller and int is bigger, it will be done. But if you try to convert integer into character, then you have to do manual casting. So we have already had a integer here, num1 equals to 10. We need to convert it into a character, or let's say we take it as 100. Now num1 will try to do manual casting for num1. So for num1 will character ch equals to, will convert it into character, and num1 will, okay, num1, and then we will be printing the character. Okay, you will see. Now I want you to guess the output. Here you give the confirmation for conversion and you will get moldy. 100 means moldy in ASCII code. You can go to Google and search for ASCII codes, and here there you will get to see. Okay, now this was about primitive. Now for non-primitive, okay, we will discuss about non-primitive conversion also. So for that, let's create a class. Here animal and a dog. Class animal, which have a method, say public void each, and then we can have a class called dog, and we can extend animal, and we have a bark method here in which we are just printing the dog is barking. And now in typecasting example, we'll just create a object using this animal parent class. We'll create an object animal, and what we are trying here, we are converting here to back to the reference of the child. Okay, so this is non-primitive conversion. I want you to guess the output. You will see that dog bark method will be called and the dog is barking will be printed here. So this was about primitive and non-primitive conversion of typecasting basically. Now if we see one short revision of this concept, so you can observe typecasting is basically a type converting one data type into the another, and there is basically two type of typecasting, that is widening and narrowing. Widening is done automatically and it's safe, whereas narrowing requires manual programming and the data loss is possible here. And in object casting we call them as upcasting or downcasting, and if you try to cast an invalid class, then it will throws the class cast exception, and arithmetic promotes smaller type 2 integer. That example we have already seen. And one line definition will be typecasting in Java is a process of converting one data type into another data type. So this was all about this typecasting concept. If you have some doubts, you can comment down below. I'll be happy to help you. So that's all. Thanks. Bye bye. And if you like my video, please do subscribe to my channel. Thanks.